Readings, calculations, and evaluations. So CRO is capable of reading frequency and time period. It is capable of recording the peak voltage, also the time interval, and it is very smart device to compare waveforms. We have a concept here that the output of a CRO is a graph of voltage against time. Output of a CRO is a graph of voltage against time. Now, this is the output of a CRO. This is the output of a CRO. Now, look at this screen. Look at this screen. This is just like a graph paper. So CRO is like a digital graph paper. You need to calibrate it and then you will get a trace on it. This is how CRO output appears, like you can see the graphs here. This is the output screen of a CRO. It is very similar to a graph paper and you need to adjust it. Number one, frequency and time period. Number one, just write number one. No need to copy because the list has been copied. So write number one and look at the formulas. Frequency is equal to 1 upon t. Frequency is equal to number of cycles upon time in second. Now you have to copy down these formulas. I'm just coming in a minute. You have to copy this screen. Look at this example. Look at this example. This is this is the output of a CRO. Y-axis is in voltage, millivolt, and time is in millisecond. And the trace is on the screen. The x-axis is 2 millisecond per division. X-axis is 2 millisecond per division. X-axis is 2 millisecond per division. So I'm working for frequency, right? For working for frequency, I can work for time period first. Time period is the time for one complete cycle. I will mark the time period on the graph. This is my, look at this. This is time period. Now you count the boxes. 1, 2, 3, 4. There are 4 boxes. Look at the scale, 2 millisecond per division. So time period will be 4 into 2, 8 millisecond. If you convert millisecond into second, it will be 8 into 10 power minus 3 second. Once you get the frequency, you will take 1 upon t. So 1 upon 8 into 10 power minus 3. Now, try this calculation and get what you are and check what you get for frequency.
Sorry, how the x-axis is 2 milli per second?
Sorry, can you repeat the question? How?
X-axis is 2 milliseconds.
Count the boxes na, for time period. Time period is one cycle.
Not the time period.
Count the boxes for one cycle. Count the boxes for one cycle. There are four boxes. And then look at the scale. Look at the scale for x-axis. The scale for x-axis is look at the scale for x-axis. It is 2 millisecond per division. Division means box. Division mean box. So multiply 2. So method is very simple. Count the boxes and multiply by the scale. The method is very simple. Count the boxes and multiply it by the scale. So can you help me to find what is the frequency?
Okay. And 25.
Sorry, 5?
125.
Good. This is the formula. In case of CRO, x-axis is commonly called time-based axis. Then now talking about peak voltage. Peak voltage is the maximum voltage. Peak voltage is the maximum voltage. It is the amplitude. It is the amplitude of the graph. Look at the screen. This is the amplitude. Now count the boxes. Look, the boxes, there are two boxes. There are two divisions, and look at the scale. So in order to find the peak voltage, you will multiply 2 by 5 and you will get 10 volt. So the method is very simple. Count the divisions in an amplitude and multiply with the scale on y-axis. This is how we measure. This is how we determine the peak voltage. You can convert it. You can also convert it into. You can also convert it into volt if needed. So write down the formula. Write number 2 peak voltage. This is the formula. So copy down this formula. Let me know once you have copied it.
Done.
Good. If if x-axis is missing, you can draw x-axis yourself in the center of the scale. You can draw x-axis in the center of the scale. CRO is an electronic device. CRO is an electronic device. Look at this output. This is the output of a CRO. I am checking for amplitude and I slightly turn on the CRO. Look at there is a trace on the screen. Now this is called calibration. Look at the screen. As I am decreasing the scale, graph is getting bigger. This is how it works. Always opposite. I'm making it bigger now, the scale. And you can see the peak voltage. This is called calibration. So CRO is calibrated in such a way that you can read the scale. You can read that screen. Now, I'm talking about frequency. I release some frequency here. Look at this screen. I'm now calibrating it. Look at the screen. It's too compact. Very compact, not readable. This is a CRO. Look at this calibration. Look at this calibration. This is called cathode ray oscilloscope. This is the screen of the device. Now, peak voltage and frequency and the shape. We want to show the sine curve. Look at this shape. Both axes are together. Now look at this screen. I am decreasing. Look the output. This is called sine wave. This is called rectangular wave. And this is called triangular wave. Three types of waves are there: sine wave, square wave, and rectangular wave.
Is an oscilloscope a CRO?
Sorry?
Is an oscilloscope a CRO?
I'm sorry, I can hear. Can you repeat the question? What they can ask you?
I'm asking if the oscilloscope and CRO the same thing.
I don't know. I'm so sorry. Actually,
Let me just
the sound issue is still there. We have tried other also Google Meet also, but there is some issue with the mic, perhaps. Uh, Perhaps you're asking that can they ask you about the CRO, but actually is in the present syllabus, they can ask you only the readings on CRO. They just ask you the readings. You're right. Sorry. In the new syllabus, they are calling it oscilloscope. They're not using the full word. Oscilloscope is a nickname for oscilloscope is actually a nickname missing the name missing words, and we use it for the same CRO. It's the same CRO, but now what they happen, they sometimes do not use the full word. If x-axis is missing, you can draw the x-axis in the center. If x-axis is missing, you can draw the x-axis in the center. We have discussed time period. We have discussed peak voltage. We have discussed these things. Example number 2. Look at this screen. This is a calibrated CRO. This is a calibrated CRO. And as I mentioned earlier, that you need to look at the scale. Okay, whenever you are reading a CRO, look at the scale. Voltage is 5. So you will count the number of divisions. You can count the boxes. Here you can even count the smaller boxes. When you are on x-axis, you have to count the number of cycle. Look, there are, if you consider the whole screen, there are 3 cycles. If you consider the whole screen, there are 3 cycles. And if you count the boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 boxes. So for 3 cycles, there are 10 division. One division is giving 2 milliseconds. So 3 cycles giving 10 into 2, 20 milliseconds. So you can convert it one cycle to get time period. You can take it X. X will be 20 upon 3 millisecond, and there you can get the time period. Once you get the time period, then you can get easily the frequency. Once you get the time period, you can easily get the frequency. Very good. Time interval. Time interval is something just like interval of two things. A CRO is a very accurate device. CRO is a very accurate device. It can measure the time period to a very high degree of accuracy. For example, you are dropping a ball. The ball comes down very quickly. CRO can even detect such a small time. Look at these two signals. The difference between the incident and reflected signal is very small. In such cases where time interval is very small, CRO can effectively detect it. So now give number 3. Give number 3. Time period. Write under it a calibrated CRO can measure very small intervals of time to a very high degree of accuracy. CRO can measure the time, small times, to a very high level of accuracy.
Um,
Now, write under it, for example, and you have to copy this example.
Done.
So when a signal reflect, this is a very short interval and CRO can detect it to a very accuracy, to a very high level of accuracy. Again, the same thing. You have to count the number of divisions between the two signals and multiply with the scale. Number of division between signals into 4. This is also an output of a CRO. Again, the same thing, multiply with the number of divisions in between. Now give number 4, comparing waveforms.
Um,
Look at the comparison. CRO is a very good device to comparing the waveforms. If you have a taste of music, then you must have seen those digital screens which show the music output also as a wave. Now these are two musical notes. This is called the difference in waveform. This is called a difference in waveform. Look at these outputs. These are 3 signals. This is called difference in output. One is a rectangular shape voltage, second is a triangle one. So CRO can compare them. CRO can compare the waveforms. Look at them. The top one is a sinusoidal one, and the second one is a rectangular one. Now you have to copy this.
done.
Now, applications of CRO as a display device to show sound signals, as a high quality voltmeter, and as a high quality stop clock. Now you have to copy this one. The structure of the oscilloscope is not required in the new course. In our previous courses, you will find in our previous past paper, 3-4 years back, you will find structures related question. They used to draw the whole CRO and they would be asking you to mark the label, but now it is not in course now. So you have to copy this syllabus link, this syllabus put here. So now change the page and put the heading nuclear physics radioactivity. This is our next chapter.
Time.
Now, this is our new chapter. This chapter starts with the concept of radioactivity. Many people hear about this nuclear physics and nuclear weapons. So radioactivity is something related to that. Give the heading, first heading, radioactivity.
Time.
I'm putting the introduction here. Radioactivity is a phenomena. It was a natural phenomena, and it was discovered by chance that there are some materials, some sources in our world which are able to emit invisible rays, and these rays are able to produce an image on a photographic film. Imaging is like that. When you take a picture through a mobile phone camera or any camera, you actually get an image on a digital medium. Similarly, when you walk in sunlight, you get an image on the ground. This is called shadow. So radioactivity was a natural phenomena. Radioactivity was a natural phenomena where some substances were able to emit radioactive rays. These rays were later discovered to be very dangerous, very dangerous. So they introduced some hazard symbols. Now copy this screen.
Time.
Radioactivity is a phenomena, is a natural phenomena where some substances were discovered and they were able to emit radioactive rays. They were very dangerous, so they introduced some hazard symbols like this and this. These are called radioactive rays. These are called radioactive rays, and these are their hazard symbols. You have to copy this screen.
Mm.
Now, these are the hazard symbols. You have to remember these hazard symbols. Now, in our chemistry base, we can remember that atom is the fundamental unit of a substance. The center is the nucleus. The center is the nucleus, and the nucleus contains protons and neutrons. Electrons are orbiting around the nucleus. The nucleus does not have a physical boundary. Proton and neutrons are inside the nucleus. Electrons normally we do not show, and protons repel each other. Some nuclei become unstable and they emit radioactive rays. These rays are emitted from the nucleus. So this is our next concept. All types of radioactive rays emit from the nucleus. You have to copy this.
Oh.
All radioactive rays are emitted from the nucleus. Radium, radon, uranium, astatine are the common examples which are naturally radioactive. Lighter elements can be radioactive also, like carbon-14 is a radioactive material. Now give a heading, analysis of radioactive emission.
Oh.
So we have started this chapter, and this chapter comes every year. This is not a very difficult chapter. We have done CRO. We have done all the electricity chapters, which are the main challenging chapters. Now, what is needed, which I